Okay, next problem. Same idea. We're dealing with these semi-hyperbola or semi-circle, but this time it has been transformed. So let's do what we always do. Let's just go ahead and figure out what all these transformations are. Easiest one to spot is that +2 at the end. It's going to shift me up 2. So I'm going to just kind of dot that in for my reference. Is that a horizontal asymptote? No. Just using it to identify where my pieces are going. Well, is this a semicircle or a semi-hyperbola? Actually, I don't even care at this point because the start is going to be exactly the same. I have x minus 3. What does that do? Shifts me to the right 3. Always, always, always. So to the right 3, like that. Is that a vertical asymptote? No. Again, it is just a point of reference. The reason I'm not putting a point there and I'm putting that liney thing is because I'm either dealing with a semicircle or a semi-hyperbola, which, if the x value is 3 is our center point, we don't have a spot on the line there in the middle between those dishy dashy dotty things. So there we have that. So I just got distracted and was showing some students videos of my dogs, and I don't have any idea what I said last. Don't know what I said last. So let's, I guess, just figure this out. So the way, again, that I keep straight which is semicircle, which is semi-hyperbola, is that I think about the basic mother function, square root, in this case, of x squared minus r squared. I square both sides. I get y squared equals x squared minus r squared, and then I get the x and the y on the same side. When I get the x and the y on the same side, you can see that you end up with one of them having a negative in front. It doesn't matter that I still have a negative on the right side because I can make that positive, and that negative. The key is that one of those has a negative on it, which means we have to be talking about our semi-hyperbola. So when I graph this in, I've shifted it right 3. I have shifted it up 2. The last thing I need to think about is this 1 right there. Remember, that is my r squared. That is the radius squared. Well, what squared gives you 1? It's got to be 1. So my radius, quote, is 1, which means I have a point 1 to the left of that key middle thingy, 1 to the right of that key middle thingy, and then I get my floppy hyperbola thingy going out like that. Except, oh wait, it's negative, so I need to make sure that that goes down. So it should look something like that and something like that. Domain and range. Domain is, again, going to be kind of tricky and goofy to do because I'm all fancy schmancy and I'm going to do it with an absolute value. So I'm going to say x is an element of R such that the absolute value of x minus 3, notice where that came from, is greater than or equal to 1. Notice where that came from. So x is an element of the interval negative infinity up to positive 2. And then I need to include that 2, and I need to union that with the set starting at my next value, which is 4, going up to positive infinity. There you have that. Range, what we got going on? Well, set builder notation. Y is an element of the set of all real numbers such that y is less than or equal to positive 2, that vertical shift value. Interval notation is going to say y is an element of the interval negative infinity up to 2. Boom, inclusive, done.